Okay, thanks, Timothy. So I want to go ahead and share my screen. That was a great session on the Dolphin scheduler. Yep. Okay, so I'll talk about Apache Druid and see if I can show a quick demo of how these two come together to orchestrate. Can you see my screen? Okay, I'm assuming everybody can see my screen. So I'm going to go ahead and. Okay, cool.
Yes, it's clear.
Okay, so this is what I'm going to do. I'm going to talk about the landscape of modern analytics, talk about what an architecture looks like for a modern analytic application, how Druid fits in, and finish up with how Druid fits into the ML pipeline, and then show a brief demo. So if you think of the story of analytics, in the 2000s, the whole notion was how can I store and process data at scale? And in the 2010s, so 2000s when you had your HDFS, data lakes, Spark, etc. The 2010s with the cloud data warehouses, the whole focus was on how to decouple compute and storage, because that obviously reduced the cost of doing analytics. But the current focus is on building an analytic application. And what is an analytic application is what we're going to come to. But typically, an analytic application is something that gives you an interactive data experience when you're processing petabytes of data, when you have thousands to hundreds to thousands of queries per second, and you're processing both real-time and historical data. The thing you see on the UI is an analytic application, right? So people are dragging and dropping stuff and seeing responses immediately and essentially having a conversation with the data, which is what the whole idea of an analytic application is. Right? So let's what examples of analytic application. These are all customers using Apache Druid. So if you think of Netflix, what Netflix is doing is analyzing their the data comes from their OTT platform in real time to get insights on what users are doing. What organizations like DBS and Visa are doing is they are using Druid to show analytics on DBS especially. What they do is they use machine learning pipeline to predict money laundering and then use Druid for a human analyst to verify whether that's really money laundering or not. And there are a number of customers who deliver analytics to their external customers. Game Analytics is a game development platform, so they give analytics to their game developers to understand what users are doing with the games. So these are some of the use cases that are used. Druid is used in. So broadly, the characteristics in these situations is that you want interactive analytics at any scale. You're looking at high concurrency at best value, and you want insights on both real-time and historical data. This is what you're looking at. Now, what's the problem with interactivity? Problem with interactivity is that because of the volume and cardinality, the rate of ingestion, and also the concurrency, we often see this spinning wheel of death. There is no interactivity. Things take seconds, minutes. Even in the interactive use case, even something like 30 seconds is really infinite, right? You don't want queries to take that long. So you really need things to happen sub-second. And that's what an interactive experience means. Now, with the cloud data warehouses, there is a lot of excitement about separation of compute and storage. But the problem is when you have extremely high concurrencies, your cost really increases a lot when you try to separate compute and storage, and you need a different approach, and that's where Druid comes in. The last thing is, there is often a need to combine streaming and batch data. What does it need? See, if you're looking at what is happening today, that is your real-time streaming data. But if you want to compare and say whether something has happened today, did it happen last week? Did it happen the quarter ago? Things like that. Then you have to combine the streaming data with the data which you already have, and you need to kind of put the results together, and that's what you need to do today to really understand what's going on. So interactive analytics at any scale, high concurrency at the best value, and insights on streaming and batch data. This is what Druid is made for. This is what Druid really does extremely well, right? So it's what the whole story is. Now, if you think of analytics on one side and applications on the other, what are the requirements? So analytics typically have requirement of doing BI reporting, handling complex queries, being able to handle big data, high cardinality data. This is what analytics cases focus on. The application or transactional databases focus on supporting transactions, asset compliance, write optimization, high concurrency, sub-second responses, and so on. Druid sits in the intersection of these two things. It can handle complex queries. It's very powerful at handling big data, extremely high cardinality data, can handle transactional events, but does not have asset compliance, gives you sub-second response under high concurrency loads. This is what an analytic application is, and Druid is the database for building a modern analytic application. Right? This is what we're thinking about. So just to summarize, these are the three requirements you want. Sub-second at any scale, high concurrency at the best value, real-time and historical insights. Why is Druid the best database to do this? Now, there are a number of things which Druid does which is unique. But traditionally, there has been this notion of the shared nothing architecture, where each node does an atomic piece of work and it does not know what the other nodes are doing. The whole thing is put together, right? So Druid does have a shared nothing architecture. But along with this, Druid also separates compute and storage to offer you the easy scalability. But then separating compute and storage completely makes it very difficult to handle concurrencies. Therefore, with Druid, what is being implemented is prefetching the data from the cloud storage into the local disk, and queries are always run on the local disk. Now, this allows for easy scalability because compute is not really attached to data. However, data is prefetched to the compute. Now, any data can come to any compute, so there is no attachment. So it allows for easy scalability and also allows us to handle concurrent queries really well. So when the data is ingested, it is segmented, it is indexed, and is usually stored in a persistent store on the cloud. The segments are prefetched to the compute nodes ready for query. And this way, clusters can grow to thousands of nodes. This is what happens. Right, so Druid gives us three things. It's very flexible because it's got elastic and distributed architecture. It's got shared nothing cluster with separation of compute and storage. It's very efficient because it is the query engine and the storage are optimized together. The query engine and the storage format, the data format, are optimized together because Druid uses an internal format. It does not store data in a standard format. It has its own format. So the query engine and the data format are optimized together, and it is resilient because there is multiple levels of data replication and automatic load balancing going on in Druid. So the data format is very unique. Data is placed in what are called segments, and it's a columnar store. Each segment is a file and a columnar store. Streaming data is held in the memory of the node doing the ingestion. You can query it directly from there. And all data is automatically indexed via bitmap indexes and dictionary encoding. And queries take a fan-out, fan-in approach for massive parallel processing. It's a scatter-gather model. That's what happens when the system is querying. So recovery is automatic because you have redundancy at all layers. So when a node goes down, another node comes up. The cluster is not disturbed. Cluster still processes queries and it still responds to queries. The Druid community is quite large, about 16,000 members in the recent numbers, about 400 contributors, about 1,000 plus companies actually using Druid. So let's see, what is the deal with the data format? So Druid does a few things with the data format. It compresses the data, dictionary encodes and compresses, uses bitmap indexes and also uses secondary indexes. And there is late materialization because filters are first applied and then aggregation is done. So this is what. So here's an example where you have data encoded as bitmap indexes, and then whenever a SQL query comes with a particular where clause becomes a binary operation because you have a bitmap index. This is kind of how this works. Okay, now the newer capability of Druid is what's called the multi-stage query engine. So traditionally, Druid is very useful for doing interactive queries, but there are use cases like reporting use cases or alerting use cases, which require more than just an interactive query. And so this is what led to the creation of what's called the multi-stage query. The current core Druid engine uses this kind of approach where the query comes to a query node and then it is scattered and then the results are gathered and put together. So this is very useful when you have the need for extremely interactive queries, but not so useful when you need reports and alerts. Right? So you need here an ability to shuffle data across nodes and across stages, right? Just like basically you need to create a DAG, and that's what happens. So we create a shuffle mesh and are able to shuffle data across nodes, across stages, and are able to hence handle the kind of queries that actually require a DAG. So this is what Druid does. So that's very brief on Druid. You can go to the druid.apache.org site and look at more stuff. I'll show you some of the other community resources we have. Now, where does Druid fit into your machine learning pipeline? So broadly speaking, with machine learning, what are you trying to do? You're trying to do exploratory data analytics, which means you want to understand how different dimensions contribute in different time periods. You want to understand behavior of metrics at different granularities and correlation among dimensions. You want to monitor the input and output of machine learning models, because if your data has got anomalies, very likely model predictions have anomalies. And you also need data to train your models. These are the three areas where Druid could potentially fit in. But with the exploratory data analytics, you want to do things like identify the number of rows with null values and drop the null values with training data. This is a filter operation, very fast in Druid. You want to look at row counts for different categorical variables. This is an aggregation, again, very, very fast in Druid. You want to do things like computing mean, standard deviation, and variance for numerical values, because these are very useful when you're doing when you want to get rid of anomalies, skews in your data before training models. These are statistics on petabytes of data, very fast. Sometimes when you're doing training forecasting models, for example, you want to aggregate at different time granularities. This is a very basically a time series query, again, very fast in Druid. And you want to look at time variation of different metrics with different dimensions, right? So how do the metrics change with different dimensions? Because your whole idea in model training is often to remove variables that are highly correlated. So these become time series queries in Druid, again, very fast. So a typical monitoring pipeline looks like this. You have your machine learning inputs coming in. You go ahead and you train a model. You have model prediction outputs. The general approach is to bring both the input and the model prediction into Kafka, ingest it to Druid in real time, and then compute anomalies in real time. So there are customers who are doing just this because the customer's whole focus is on offering machine learning as a service to their customers. And if there are anomalies in the model, it affects their customers and hence their overall business, and they want to avoid that. Okay, so that a typical anomaly detection kind of sequence. So you typically have a sequence of metrics, and you want to find what is an anomaly. And what is an anomaly is something you need to understand by looking at different time intervals, which means you need to go back in time, look at last week's data, look at previous month's data, and so on. So it's extremely important to be able to do that, and that's what Druid does well. Model training, you need to extract different types of data, train models on different granularities and compare the accuracy. And often, if you're doing things like training a genetic algorithm, you want to extract thousands of data points from your data lake. And that's very difficult to do in the absence of a high-performance engine like Druid. Okay, so before I do this on what's the community resource available, I just quickly set up a demo. And I have a Druid cluster here. This is what's called the Druid console. You can see a bunch of tables here. You can see some ingestions running through. Now, my task here is that I have a S3 bucket. Let me just see, get that properly positioned here. I have an S3 bucket. I have some data here. So this S3 is a local S3 I've set just for this demo. This is, if you don't know, this is MiniIO, which is simulates S3 in your local setup. So you can use this. So I've got a CSV file which I want to ingest into Druid. So the use case typically is you have order data coming into S3 and you need to ingest it into Druid and start doing analytics. This is what the use case is. And what I did was I set up a simple workflow here in the Dolphin scheduler. Very simple workflow with one task, which is essentially a quick curl command, which basically hits the Druid API. So you can see the command here. So I created a thing called ingestion spec in Druid, and I'm passing it to the Druid API using the Dolphin scheduler. This is a very normal requirement when you're dealing with Druid, because Druid does not provide the ability to schedule an ingestion. Real-time ingestion is continuously running. But batch ingestion is something that starts and shut down, and you need to be able to start it when you have data to be ingested, so that you have to either run it through some kind of cron job or use a scheduler like Dolphin scheduler to do this. And that's what I've done here. I can go ahead and run this workflow here real quick. Pick this worker. I could have just time scheduled it, but the purpose of this demo, I'm just going to run it here. And if I go back to my Druid console, you can see this started running this ingestion here. It will take a few seconds to finish up. Typically, it takes about, because it's a small set of data, a few thousand rows, it takes a few seconds to finish up. And the idea is that your data comes into S3, you're running it on schedule, ingesting data into it. It's done, and then you go in here and actually you can start querying that data. This is my table I ingested here, orders test. You can see order ID, delivery date, and all that. I can start running queries here. I can do typical SQL queries here in Druid, and let's do that real quick here. You can start doing your analytics, right? So this is what brings these two tools together to actually be able to orchestrate workflows which ingest data into Druid, and from there you can do your analytics. Right, so that's the quick demo I wanted to show of how these two tools come together. Now, Druid, of course, is also an open source tool. So here are some of the resources. There's a community Slack channel. You can go join the Slack channel. The implies, of course, the company that is commercially backing Druid, but Imply offers POC clinics to our open source users. These are not Imply product sessions. This is absolutely Druid POC clinic. So if you are trying out open source Druid, you want help, please do come to that POC clinic. We also offer tech talks about Druid to anybody who's interested in open source Druid, wants to use open source Druid. We can get on and explain what it does, how it does, what's the best place to use it. The number of open source blogs being put together by me and my colleagues, and these are all available for you to consume. I have one on, using Druid with NiFi, Apache NiFi, and Apache Kafka to get data from GitHub and do some analysis, GitHub repositories, analyze the stars and things like that. So a very interesting thing here. One on how to do machine learning model training with Druid. I've got you can take a quick look at this here. It's got a Jupyter notebook here. I've got some code here, so you can definitely take a look at it. So I've got all this checked into GitHub, so you can go play with it, use it for your own projects and so on. So this is all offered by our Imply open source team. Yeah, so the Druid Slack channel, you can use this QR code to join and ask questions, try to make use of Druid. So it's pretty much what I had. I'm going to stop sharing. So I think if any questions are there, we can take it. Otherwise, I guess we're done. Yeah, any questions, comments, thoughts, please feel free. Um, okay, I guess